Hello, everybody. This is Derek. We've got a lot of people still joining in, so we will wait for just a couple more minutes, and then I will get started. Thanks. Okay, so hello, everybody. My name is Derek Kominick. I'm the Senior Consulting Manager here at Matrikon Honeywell. And in today's session, I'm going to be talking about OPC security and how to, let's say, minimize the risks of being attacked, or at least the negative repercussions if you get attacked by malware or otherwise users and such. So the things that I'll go over, I'll cover a little bit about what the what the modern attacks look like and how they're evolving, the cyber attacks, and how the software is evolving and sort of the attack process. And then I will talk about OPC vulnerabilities that exist and how to try to minimize them, and basically go over 5 key steps, let's say, that would help you, again, to minimize the various risks that are present. So first of all, as you look around the world right now, there's a lot of different initiatives that are happening in order to maximize the value of all the data that sits in all our assets. Given the huge movement towards industrial Internet of Things and Industry 4.0, both being basically synonymous for what they're trying to achieve. Connecting more assets and reaching deeper into the shop floor and trying to share the data in order to better process it and act on it is definitely something that's appealing. Huge projections abound as far as what this is going to do for the economy and efficiencies. So there's a lot of interest in this, obviously. And this basically applies to every industry you can think of, right? So, of course, in the process industries, in whether it be oil and gas, in power, especially in process industries where you've got a lot of distributed assets or things are heavily interconnected, naturally you're going to need or you'll benefit from additional visibility into the multitude of assets and drawing the conclusions, let's say, on what the data means as you start to combine it and work with it. So across the board, we can see that people are increasingly interested in how to properly connect their various assets, and then they're asking, what can we do once we pool the data together and start to work with it. So this is the good part, the positive side of things. But there's also a problem that a lot of times the way things are set up, either from the past where we used to rely on security by obscurity or just not having a proper handoff, let's say, between what IT does in order to establish secure systems and what OT does in order to keep things running, keep the lights on. Of course, you can lose visibility. So even though the promise is that you can do more with the technology as you connect, if you obviously don't have it protected the right way, that also increases the chances of how much damage can happen, either physical or basically just within the process if systems are taken down. So of course, that's why you guys are here at this presentation. Cybersecurity, which involves both IT and OT type activities, helps to reduce the chances of having your systems being taken down by malware or some kind of attack, some kind of cyber attack. Now, one key thing to note on this is that no system is impervious to any type of attack. So there's always something that can go wrong, or people find a way in, the wrong guys, the bad guys. But at the same time, there's a lot you can do to either help prevent certain types of attacks, or at least to detect or slow down the attacks so that, for example, they can be noticed and you can against them. And if you can't stop it, then at least to minimize the damage that can be done. Now, recent examples of some of these, let's say, increasingly severe attacks. First one that really hit the news, this is a while back now, but many of you might remember it. So the Stuxnet attack that happened in Iran on their centrifuges back in 2010, that was something that was specifically aimed at ICS, or industrial control systems, where basically you are removing control from the operators as to what's happening with the centrifuge. So basically it was what it was designed to do was to use a particular vendor's system, so targeted Siemens controllers, and it was accelerating the centrifuges beyond the specs of what they could handle. So basically they were tearing themselves apart, but at the same time it was indicating to the operators that everything is fine. And over time, of course, they would continue to run the centrifuges, and they would continually break down, and it completely messed up or at least slow down the process, what Iran was working on. Now that was before, and that was a very targeted, very specific type of attack against specific equipment at a specific location. Now, fast forward to 2016, and basically at the end of 2016 in Ukraine, as you know, Ukraine is having conflict with Russia. And what happened was the Russians attacked the Ukrainian power grid. And the particular attack that they used, which the reports of which have been issued now, mid-2017, has been dubbed crash override. And what this attack did was penetrate into the substations and start to flip breakers on and off repeatedly, quickly, in each of the substations. Now, when that happens in the substation, the systems are designed to, of course, protect the substation and ensure that it's not going to cause trouble on the grid overall, so it causes it to shut down. Now, while these breakers were being flipped in order to set off the process security mechanisms to start shutting it down, at the same time, software, other parts of the same malware attack were telling operators that everything is fine and locking them out so they actually couldn't control the breakers even if they tried. So this put them in a real precarious situation because things were happening in the plants which A, they didn't know were happening, and B, they couldn't affect through the PC systems even if they tried. Once that's that process started and they attacked multiple substations at the same time, basically all the substations started shutting themselves down, which effectively created a blackout, and the operators couldn't reverse it. And just to make things a little bit more fun, the software also then started wiping the computers it was running on. So not only could they, not use the software because they were getting locked out, but the actual drives on the PC started going down, and the PCs basically became inoperable. So this was a multifaceted attack that not only got through, obviously, the IT security in the system, but it also attacked the actual process itself. Right? So this is a much more sophisticated type of attack. Now, for those of you who may be interested in this, there's some very good reports written on the topic. So ESET and Dragos both have issued quite lengthy reports that go through in detail, much more than I'll be going through here, as far as how this worked. I'll just cover sort of the broad stroke, high-level aspects of this type of attack to give you guys a feel for what that attack looked like, and then we'll talk about what OPC has to do with this. So one thing to note, when you talk about attacks on control systems or on plants and etc., they don't just happen overnight, right? So when an attack is getting started, or when someone's planning to do an attack, there are actually a lot of steps that the attackers go through, meticulously gathering information, continually feeding information back once they, let's say, penetrate into a facility or multiple facilities. Then they prepare the attack. A lot of times the malware will communicate back to a command and control center somewhere on the net in order to feed information back and let's say set up the attack in such a way so it'll be most effective. So this happens over time. This is an ongoing process. It's not a one-time shot. So the key thing is that it's probably not going to be the case that somebody comes in and can deploy such a sophisticated attack just overnight, right? So since it takes time, we also then on the side of trying to make things run, have time to also prepare and to implement various strategies or called defense in depth in order to help to prevent, or at least to be able to detect when these things are happening, when we have anomalies in how the network is being used, which devices are getting pinged, what type of messaging is going across. So all of those, there's time in order to start to prepare for this because it doesn't happen overnight. So the good news is there's time to prepare for such things. The bad news is that they're very meticulous. So as they get set up, they're very thorough. So whatever gaps you have in your security, eventually they get discovered as these types of attacks get more sophisticated. So the first step is actually just education and becoming aware of how many levels this is happening at. And by the way, this isn't something that just happens technically in isolation, that a program is installed and then it just does its own thing. There's all sorts of groups that are working together in unison to make this happen. So whether it's people dropping USB drives in the parking lot, like they did with Stuxnet, so somebody picks up the USB drive, goes back in the facility and is curious what's on the USB drives, plugs it in, and then off it goes. It starts installing something on the office computer, and then the malware starts to do its thing, crawling through the network, trying to find its way in. Sometimes people send emails. A recent report on phishing came through and indicated that I think it was 91% of all attacks start off with a phishing type attack, where basically people are opening up PDFs or various types of attachments, and that's one of the easier ways to get some kind of malware into the system to begin this whole process, before finally you get to the point where you're launching attacks. So it takes a while. Now, if you were to look at the different types of attacks that have happened, I mean, there's a lot, right? The ones that I show here are sort of the highlights, or the ones that I guess there was more visibility for in general media, or just you can easily access. But basically, whether we start off with Stuxnet, and then when the source code for that got out, There are other, let's see, genealogies of attack software that were created, and they actually float around and get modified. So people don't just go out and invent their own. Quite often what will happen is they'll take something that worked before, they'll modify a little bit. It's like the evolution of the software to be more and more, let's say, effective, right? So over time as we go, we can see how the analysts, especially when they go through and they look at the code, there are certain characteristics in the malware that as they analyze the source code, they can actually identify which groups, for example, worked on it, the certain standard modes of operation that they use that are recognizable. So some of the software that gets created or the early systems were used for espionage, right? So it doesn't always have to be set up for just attacking systems and wrecking things. Sometimes it's actually to see how things are done, because there's proprietary processes that are done. So one country might spy on another industry in order to copy some of the processes that they're using, some advanced manufacturing techniques and such. So it doesn't always have to be with the intent to destroy something. It can also be to gain access to information that they weren't privy to. Okay, so as we go through and we see that initially we've on the left we've got the Stuxnet, like I said, which was designed to specifically attack a type of PLC and in a particular application. And then as we go off to the right, we start to see that the attack gets a bit more broad. So finally, again, when we get to the far right and we start talking about the crash override, the key distinguishing feature in crash override is just how modular it is. So rather than being custom written for a specific system, it actually is multifaceted. So imagine modules being added, which actually allow it to perform different types of infiltration and different types of attack. And I'll get to a little bit more detail on that shortly. But in the end, things are getting more sophisticated on that side. Now, when we talk about attacking industrial systems, there are various sort of levels, I guess, at which you can come in, and a lot of times multiple levels or all of them will be sort of attacked at some point or other as they sort of structure their attack. So whether you're doing a physical exploit where you're actually gaining access to systems, whether you're talking to ICS vendor systems, right? So that's actually attacking specifically control system vendor, either applications or the controllers that they have, the particular devices for control, or there's of course the IT type policy exploits. So whether people have weak passwords or the firewalls aren't configured correctly, so you can start to come in and actually attack the network, and then eventually get to the next stage, which would be actually attacking the control systems to eventually get to the physical exploits. And then I've also added a level that I just call process exploits. And what this does is it starts to use the regular process that normally would run in a plant, power plant, refinery, whichever, where nothing appears to be out of place. It's just that the wrong steps are starting to be introduced into the process in order to cause damage. Whether that's opening and closing valves in the wrong sequence in the pipeline, that can have catastrophic effects if you consider the pressure and the amount of oil that's being transported. Whether it's flipping breakers in substations, these are things that you wouldn't detect if you're looking for incorrect packets being sent, because they're actually using correct packets. They're just actually attacking the process itself. So they still need to gain access into the system, but then they hide within the system because all the commands that they're issuing are actually valid, right? So those are sort of when you're thinking about the types of attacks, there are different layers that you start to consider. So when we talk about the vendor exploits, some of the things to think about, the software exploits. So there might be the zero-day type bugs where things are discovered and basically there's a gap. You can cause either something to crash, or you cause a memory overflow if you send the wrong type of information to it, which will then allow you to potentially get into the OS and start attacking the system. There could be application exploits. This is more within context. So one of the things I'll be talking about is the difference between security from an IT perspective and security, let's say, from an OT perspective. So from an IT perspective, you're trying to get through, obviously, log on. You're trying to become a user, hopefully with as much, from an attacker's point of view, hopefully, with as much privilege as possible, so like an administrator, because, again, that allows you the freedom to move around the network and access all the resources and control them from an IT perspective. From a OT perspective, when you're trying to attack the system, you're less concerned about that. Let's say you'd have to assume that you've got into that. But now what you're trying to do is actually move through the control software in order to gain access to the functions within an application, right? So whether you're doing something within an HMI, whether you're communicating with various types of controllers over various protocols, that's basically the information that you're sending and the values that you're transmitting. That's not necessarily an IT focus, that is an OT focus. And that's actually something that we'll be drilling down into. Now, just to get to look into, what happens with the attack software, I said that it's getting more sophisticated because it's becoming more modular. There are some other types of diagrams, especially in the reports that I mentioned from Dragos and such, that show, in more detail how the attack software works. But from a high-level perspective, to not deep dive too much, basically there are two parts to the software. So first, the software facilitates, let's call it an attack framework, right? So they've actually got functions that will try to propagate through the system using various techniques. It will have various methods of collecting information about the network. Because if you think about it, the software comes in and has to discover what PCs are where. They build a lot of smarts into the system to try to avoid, for example, honeypots. So basically companies will deploy parts of a network that actually look like a real network, but they actually aren't. It's just meant to actually trap software that's coming in and trying to, for example, move through the network and spy, right? Or just do something that's out of character. So of course, on the good guys side, we get more sophisticated in how we try to trap some of this malware or detect it. They build additional modules also to try to sort of stay ahead of that. And then, of course, there are, I just call them sabotage functions, but basically the different types of havoc that the software might start using at some point, right? So you've got teams of developers that worked on that part. They sort of specialize in that. But then you get more to what we're interested in, which is these specialized modules that started to show up, where instead of the entire framework being designed for example, like we saw in Stuxnet, against a particular vendor's equipment, now what they're doing is these modules are interchangeable. So you've got this flexible framework, and then you get experts on the bad side who come in and start targeting either specific vendor equipment, or they start targeting how to implement and use various protocols in a legitimate way, but again, to start actually targeting the process that's relying on those protocols in order to do something. So in this case, we were talking about, I'm using the Ukraine example. So there are various power station or power industry specific protocols. So the 6870 protocols, both the 101 and 104 standards, 61850, and OPC DA also was used in this attack. So hence the connection to our presentation here, talking about OPC vulnerabilities. So in this case, OPC DA was not used to actually eventually do any type of attack or even to do the writes, to try to control systems. But what it did do is when an OPC client was connecting to an OPC server, it would when it connects to the server, it starts to obviously find out what type of items are available on that server. It can find what OPC servers exist on PCs to help better profile which PC you're on, whether it's, again, an office PC or are you on a control floor, shop floor type PC where now you are working with, it's connected to various types of controllers, because based on what type of OPC servers you find on that PC, it lets you know roughly what that PC is being used for, right? So part of the profiling and sort of the espionage type function or the reconnaissance that the malware was doing, again, it was using these specialized modules. So, in this case, the attack, the crash override that I'm talking about, I mean, they chose to use these specific protocols in a specific way. But the next attack that happens, again, would reuse this overall flexible framework but could target other systems and do other things with these types of exploits. So definitely they're upping the ante as far as just what's possible once they start to get into your systems. So this is why I thought it was important to run through and, number one, generate this awareness of what these systems are doing and how specialized they're getting, but also what can you do about it? Because otherwise it's just a depressing conversation. Okay, so one thing to note, we're not going to solve all the security problems with a single technology, a very specific one at that, which is OPC. So there's this concept of defense in depth, which basically at its sort of simplest just means that you've got various components in your infrastructure, right? So you're going to have devices, controllers. I didn't put every box for every type, but you've got devices, you've got your networks and trying to run the networks themselves. You got obviously PCs running different operating systems. Within that, you've got applications running on those systems, and then you've got an overall process that you've set up of how things are supposed to run and work with each other. So the idea in defense in depth is to say you don't want to make one sort of one wall around things and basically say, okay, now I've protected my system. What you want to do is you want to work out the security for each layer and each application. For example, let's say in the software box, you've got multiple applications, so your HMI is going to have certain type of security. Your historian is going to have a certain type of security. Your OPC servers running in the software box, they're on particular PCs. They're going to have different types of security. So you want to set up different layers of security which use slightly different methods of protection or security mechanisms so that not everybody is using the same, let's say, lock, right? If you have a building that has all doors locked, but every door uses the same key, well, obviously once someone gets that key, they're going to get through and they have much easier time moving through your entire building. If you have different keys for different floors or different doors, obviously that gets a little bit harder to beat. And it might be some electronic keys, some are the cards, access cards, others physical keys. So the point is, when we're dealing with defense in depth, you want to make sure that you're using various strategies that each of the technologies makes available, and in total, that just slows the process down. Because as you saw in that slide that I showed previously, the many steps that are taken before an attack really is fully deployed and launched, there's a lot that they have to go through. And the longer it takes an attacker to get the information they need and then to set up their systems to actually do the attack, the higher the chance you can discover an anomaly and then stop it or prevent it if it's possible. So taking a look at the software, kind of diving into the software part of it, if we look at, when we start talking about OPC specifically, what are some of the things that we deal with? Well, so starting from the top, number one, when someone logs onto a PC or when they're running the OPC clients and servers, they're going to have to run as some kind of user. So the scenarios are you might have a valid user, you might have a valid user account that got compromised, or you've got a rogue user who wasn't even supposed to be on the system, but now they are, right? So you've got sort of different scenarios there. You also have different types of applications that act as the clients. So the parts that are controlling, or they're the masters in the client-server relationship. And those again might be valid applications, or you could also have a rogue or a compromised application where users are connecting through it, and then they're talking to actual OPC servers, which then talk downwards to your various types of controllers and such, which then again talk to your actual end devices, like, for example, the RTUs that were controlling the circuit breakers in the Ukraine substations. Okay, so what we're looking at in this presentation is when we start focusing on the OPC context. So again, even in this box, you will have IT concepts of how do you set up users on the PC, how do you ensure that, they have the right passwords and, what permissions do they have, etc. Where can the applications be installed? What firewalls do you have to traverse in order to communicate between the client and the server? So there's a lot of other issues that we would have to deal with to take the whole picture in mind. But again, what we're going to focus on here is if you are talking about a client trying to communicate with a server, what can the OPC server do, or what can you do about the communications between those two in order to ensure you've got maximum, let's say, security for this type of communication? Okay, so that's sort of where I'm focusing on. So let's jump into, let's look at OPC vulnerabilities and what we can do about them. So again, from an IT perspective, when we are talking about OPC, number one, OPC Classic. So by the way, I'm going to be, splitting this conversation sort of into two, where it makes sense. There's OPC Classic, which is the first generation of OPC. The majority of the world right now runs still on Classic OPC because there's, been 20 years of deployment of this stuff. So obviously there's going to be a lot of it out there. And then there's OPC UA, which is the next generation of OPC, which completely sort of rethinks the model of how you facilitate communications between clients and servers and what that even means. So there are two standards we talk about. Because the majority of the world is still using OPC Classic, I focus a lot on that because, as you would guess, 20 years ago, our perception of what's secure and what's needed for security and where OPC shows up was quite different than what we see today. So, returning to this slide, when we talk about OPC Classic related threat vectors from an IT perspective, the biggest one that flares up always is DCOM, right? So, the operating system, Windows has COM and DCOM, stands for component object model, or if you're talking between PCs, DCOM, which is distributed component object model. And what that basically means is that that's how the operating system allows all the different objects within it, the components, to communicate amongst each other, either on the PC or even between PCs. So Windows tried to, or Microsoft basically, the effort there was to abstract the network away so that you're not worrying about how to write applications that can communicate across the network. The operating system was meant to facilitate that, not only for applications that various other vendors wrote, but also for how Windows actually did its own internal communications or facilitating running applications. So not something you easily tear out. It was sort of in the heart of the Windows operating system. Okay, so the types of issues that you have with DCOM when it's being used or when it gets breached is obviously intrusion and propagation throughout the network. You can also start to control the system because, again, if you're dealing with applications and starting them and stopping them, changing permissions and such, you basically gain control of the PC once you compromise the DCOM security, which then, of course, from an IT perspective, leads to either espionage, where you're actually looking at getting into things that you shouldn't, or you're actually able to cause havoc, that is sabotage. And then network issues, same thing. So when OPC Classic is being used, OPC Classic does not have encryption built into it. So whether you're trying to, again, change data or you're trying to just get access to data, that creates an issue. From an OT perspective or a process perspective, it's actually the behavior of the server. So not things that are happening as data travels outside of the server, but once you are connected to the server, you sort of change your mindset and say, okay, what's actually happening on the server? Well, when a client connects to an OPC server, it starts to look at what tags are available. Can it read the tags? Can it write to the tags? And depending on what's being done and what those tags represent, you're either spying on somebody or you're causing havoc. You're damaging things, right? Sabotaging things. So those are the sort of the threats that the most common threats that you would face when you're dealing with OPC Classic. Now, one thing that I wanted to touch on here is, again, I mentioned that OPC UA is the second generation of OPC. Now, as it turns out, in Europe, some of you may be familiar, they have Industry 4.0, which is sort of the equivalent or the same thing that we're doing with Industrial Internet of Things. And one of the things that the German government wanted to do is to say, okay, if we're going to run this Industry 4.0, we want to make sure that the standard, the data connectivity standard that's used is going to be secure. It also had to have other functions like you have to be robust, maintain context, be able to run on all sorts of environments, large systems, small devices, etc. But anyways, they ended up testing basically everything they could find, all sorts of potentially useful standards for communications. But after they did all the testing, they basically found that OPC UA was the one that was the most secure and the most capable of supporting Industry 4.0. So just to give you an idea of the types of testing that they've done and the types of things that OPC UA is designed to actually protect against, this is a table that was actually put together by the BSI. So BSI, by the way, is let's call it the equivalent of the FBI in the States, right? So basically they deal with all forms of security and crime prevention and such. So anyways, they commissioned testing, independent testing of various standards, and this is what was tested for OPC UA to ensure that the types of attacks that can happen on, when you're running an OPC server, a UA server, so the attacks are shown in the column, in the first column, and then going across the different columns indicate the types of data security that would get breached. Attack was successful. So this is kind of a map of the types of attacks. And basically, the end result was that OPC UA passed, right? So the mechanisms that are built into OPC UA in order to prevent these types of attacks is sufficient and holds water. So basically, when they stress tested the servers, they attacked them in a lab environment, they passed. Okay, so one thing to keep in mind that if you are, working on your OPC strategy and such, definitely coming up with a plan to shift or to start moving to OPC UA from OPC Classic, definitely a prudent move. All right. So having said that, what are the 5 steps that you could take to improve your OPC security? So basically, the ones I'm going to cover in the next 5 slides is eliminating the use of DCOM, encrypting your data, locking down your OPC server, so the access that you give to OPC clients once they actually connect, the ability to do assessments of your OPC implementations, and to ensure that your people or yourself, if you're responsible for working with OPC, that you have the right training so you actually understand the technology you're working with. Right? The bad guys definitely make sure they understand it. So number 1, stop using DCOM. Right? So this is a OPC Classic problem. So OPC Classic, as mentioned, it actually is based on the assumption that the data communications, the transport is going to be going over DCOM. And since DCOM is vulnerable to attacks, obviously it's a problem for IT, and that's come in the Classic days, OPC Classic days, you have a lot of conflict between IT and OT because OT needed the data to keep flowing and they needed to communicate with the various devices through OPC Classic. But by doing that, they needed to open up DCOM ports, which meant that the system overall, from an IT perspective, was more vulnerable. So obviously, that was a bone of contention, caused a lot of issues. Now, of course, one of the fastest ways to change this, if you're not migrating to OPC UA, which, by the way, doesn't have this problem at all because it doesn't use OPC UA. I mean, OPC UA does not use DCOM at all, is to use OPC UA Tunneler. Right? So Matrikon has basically an application that's been used for years, which basically eliminates the use of DCOM between clients and servers. It facilitates the communications. You still get the same information. It works with all third-party servers and clients because on each end it actually talks OPC, but in between it actually does not use DCOM. So if you're not moving anytime soon from OPC Classic to OPC UA, but you are using, you're still talking between systems using OPC Classic, this is definitely a very quick way to shut, to eliminate the use of DCOM. Now, some people will say, yeah, but you can limit the number of ports that you have to have open, let's say on a firewall, in order to facilitate OPC communications. That's actually a bit of a fallacy, because even if you have one DCOM port open, that's all that's needed, right? It's not. I mean, if you have 10 or 100 ports that potentially can be used for DCOM communications, I mean, yes, that makes it even easier to find one of them. But in the end, even if you have one, it will be found, and the system will still get attacked the same way, whether it was one port or 100 that are open. So eliminating DCOM, definitely a good move. Number 2 is to encrypt your data. Now here again, you've got 2 different scenarios. In OPC Classic, there is no encryption. Basically, you're using the COM-DCOM transports. Data is sent as clear text. And again, Tunneler has that built in. So if you are going to stay with OPC Classic and you're transmitting data that's sensitive that you wouldn't want someone to be able to gain access to, either to see or potentially to tamper with, then Tunneler would do that job. Of course, a preferred route, if you're going to go to OPC UA, then you're eliminating this, and OPC UA actually has encryption and signing built into it, which means that depending on the level of security that you have to implement, and again, that may be dependent on the types of systems you're dealing with, right? The smaller the processor on the device, the less horsepower it's going to have to do the job it needs to do, plus to do the encryption or signing of messages. The more power, obviously, the more it can. So OPC UA is flexible to allow you to choose what type of security you want to implement. You could turn it off completely as well in certain cases, but it's advised not to if you at all can. So you can sign your data being sent, which means signing means that it can't be tampered with. It doesn't mean if somebody captures it, they can still see the contents of the packets as they're going through, but they can't change them because they're signed. So basically, the check won't work when it arrives at the server or the client. Encryption, obviously, you're now scrambling the data, so even if they capture the packet, they can't get any useful information out of it anytime soon, right? So the stronger the encryption, the longer it would take to break eventually. By that time, it might not be useful for them anymore. And then there's also signing and encryption. Now, one thing to keep in mind when we talk about OPC UA being secure, when you talk about data, it actually has sort of 3 states that you would want to focus on when you're trying to protect it. So there's data at rest, which means how do you protect the data as it's stored? There's data in process, which means when it's going through an application, how do you ensure that you can't do something to that data as it's being worked on by an application, right? So the results that the application is generating, et cetera. And then there's data in motion, which is basically transferring data from point A to point B. So the type of security that we talk about, whether it's OPC UA or OPC Classic, deals with that last part. It's how you transmit data from A to B. Okay, so just to be sure that we're clear, because how you would protect your historian data, for example, would be outside the context of what OPC security does for you. So OPC is used for transferring data, and therefore we're talking about security for data in motion. Okay, so in this case, whether you're doing whether you want to continue to use Classic because you're not ready to move forward or just don't plan to, Tunneler can provide that type of data encryption between Classic clients and servers. It can also facilitate the migration. So if you decide, do wants to move towards UA but can't switch everything over at once, then of course you can also use the same application, and it will allow Classic and UA components to communicate between each other. And again, obviously without using DCOM. Okay, the third item is to lock down the servers, but this is more on once you connect to the server, but now the question is, what can you do on that server, right? So the majority of implemented OPC servers that exist for OPC Classic do not include per user per tag security, which means that when you're a particular user logged into, let's say, Windows, and you're running an application, so your token of who you are gets passed to the server, as long as you're allowed to connect to the server opens up for you, and you can basically access whatever tags it has available. You can browse them. If they're set up for read-write, then you get read-write. If they're read-only, then you only get read-only. But the point is that it's sort of indiscriminate. Whoever gets through the front door gets to access whatever they want or to see whatever they want on what that server has. So there is actually a way to protect them. Now, Matrikon offers a couple options here. If you're dealing with third-party systems which don't have the security. So you've got a third-party OPC server, and you've got different people connecting to it. So whether it's an operator or it's a manager, engineer, or for example, some interlopers, so you're a bad guy. Not all, number one, the bad guy obviously shouldn't have any access to the system. And number two, certain people shouldn't have access to everything on that server either, right? They might not have the knowledge or even the need for them to have access to everything on that server. So if security is not implemented, then basically, you're running into a problem there. Now, one thing to note, Matrikon OPC servers actually have security built into their framework. If you are using Matrikon OPC servers, you can activate the security framework on them, and they will actually implement per user per tag. But there's also another answer, and that is to use what we call OPC Security Gateway. And this is an application that will work with any of your OPC servers that you may have deployed now. And you basically set them up to only communicate with the security gateway. And it actually implements on their behalf security on a per user per tag level. So what would happen is if a particular user is not in its access list, then they would not get any access to the server. If they are on the access list, you can limit down again. If you have more sensitive data, you can identify which items those are on the server, and you can prevent particular users to gain access to particular types of information. So the operator will get the types of information that the operator needs for their station or their area. The manager might get production data, so maybe there are some, there's some information as far as, the throughput or the yield that comes through, but not some of the information that's related to controlling the actual system. Engineer might get everything, and the bad guy obviously gets locked out. So you can create basically a additional layer of security, so literally security in depth, where even if somebody, let's say that the operator's account got compromised, well, the only thing that you'll be able to access then, whoever compromised that account, they would only get the functionality that the operator has. Again, that doesn't prevent, security gateway wouldn't be able to identify that, hey, wait a second, this operator now, even though they're valid, they shouldn't get access to what they could access yesterday, but at least it will limit what they can do. So if the wrong account gets compromised, only the capabilities that account has will be given to the attacker, as opposed to having a wide open server where all the information gets exposed. So that's the role of security gateway. And again, it can wrap, like the blue box shows there at the bottom, one or more OPC servers basically sitting on a PC. So that way you set up the settings on the server so they don't accept connections from any other applications, and they'll only work with the security gateway, and therefore everybody has to go through the security gateway, whether it's local or remote. This also is compatible with the tunneler software, so on top of that you can of course have the data encrypted, and you eliminate the use of DCOM. Okay, the next part is making sure that you actually take a look at what you've got deployed now. A lot of the systems that were deployed over the past 20 years were sort of done, kind of a white knuckle ride where you're coming in, DCOM is very fickle, and you're trying to get the system to work. So you're opening up your firewalls, you're setting all the DCOM settings to be basically as permissive as possible, granting permission to everyone in the ACL, the access control list, to basically just make the thing work, right? Because it sometimes was tricky to actually get it to work. So for that point, you actually want to go through and take a look what you have running now, running day to day, and say, okay, well, don't want to disrupt anything, but at the same time, you need to take a look and identify what are the risks, right? So if you don't, and you do get malware in there, it will identify them for you, but with pretty negative consequences. Okay, so it's a good idea to run through and actually do assessments. That's just, like I said, you can't fix what you don't know. The fifth item is making sure that you train your workforce, right? So just like we say that security in IT terms, or in the IT world, is not just about passwords and and virus checkers, you also have to have a culture of security. Well, the same thing when you're dealing with OPC, you have to actually use OPC the correct way. So people do need to understand something about how OPC functions or the right way to use it in order to deploy it. If they're the administrators, or if they're trying to use it, also to understand, what are the capabilities and what are the limitations of what you can and cannot do. Now, there are, again, Matrikon, having dealt with OPC for the last 20 years, we do have courses for that. So whether you're trying to learn more about the security, or you're trying to learn about migration, or how to implement the UA side of things, whatever sort of step of the journey you're on, whether you're using Classic, migrating, or already on using OPC UA and just trying to figure out how to use it correctly, there are options to do that as well. So going to this one, again, it's time well spent. Even taking introductory courses helps because, again, when you're familiar with the technology, you can better use it. Otherwise, it's you just try to get it to work, and then hopefully that's all you have to do. But it's important to understand the underlying technology. Okay, so guys, those are the 5 steps. I mean, that's, we've covered what the attacks look like and sort of how they're evolving, what the vulnerabilities are, the fact that you've got different perspectives between what someone from IT would think is necessary to do for security versus someone who has knowledge about the actual process that you're implementing, and therefore what could go wrong there and how to protect that using the tools, the OPC servers, or within the actual OPC server, or the HMIs, and etc. So from the process perspective, right? So really for you, the next steps based on what I talked about here. I mean, if you guys are looking to to improve the security, let's say, of your systems, we have OPC UA Tunneler. Now, by the way, UA Tunneler, which is the next generation of OPC Tunneler, is coming out at the end of this month, and it will be replacing or implementing the same functionality as today's OPC Tunneler, UA Wrapper, and Proxy, which is used for OPC UA migrations. So all of that's brought together under a single user interface. It's just a lot easier to use. So whether you're trying to protect your Classic systems, or you're trying to facilitate the meshing of UA and Classic, you can do those. Also talked about Security Gateway for locking down what you can do on an OPC server once you actually connect, right? So how do you limit what users can do on a particular OPC server, regardless of what vendor it comes from? That's what that one is for. And then also, of course, if you're looking for information on getting more training for OPC, about OPC, whether Classic UA or security, we have that. Matrikon has a lot of educational collateral on our site, so you can also do that. I highly encourage you to take a look at what we have. And then also we do assessments and consulting. So some companies aren't ready to just jump in and start doing shifting to OPC UA just full bore without first testing it or seeing how it would work with their systems. So if you're looking to do proof of concepts, or just you already know what your migration path is and you're looking for components to implement piecewise in order to move from Classic to UA, that is something that Matrikon can help you with as well. So definitely contact us if you're interested in pursuing that. Okay, now all of this information will be sent to you after the presentation. So we'll make sure that you get the links to this, and also contact information in case you have further questions. Now, I know that we've gone over some of the allotted time, so if you do have questions, please feel free to contact me. At this stage, I won't be able to take any questions, but my contact information is here. And at the same time, you can it'll be sent to you after the presentation. Okay, so guys, thank you very much for attending the presentation. I hope that you found it informative and hopefully useful for some of the next steps that you can take to secure your OPC systems. And yeah, till we talk again. Thanks a lot.